In section 19.3, we want to talk about the electrophilic aromatic sulfonation reaction. Sulfonation reactions put on a sulfonic acid group. Now, so remember, there's 3 steps to each of these reactions. The first thing you want to do is create the electrophile. That might be 1, 2, 3 steps. And then the phenyl ring is going to attack that, and then you have something within the solvent mixture, the reaction mixture, that's going to deprotonate. Okay? Now, this reaction is an equilibrium reaction, so what that means is if you have benzene like this, and I'll just draw the H here, and we add fuming sulfuric acid, okay? So I'll put H2SO4 in here, and this is in equilibrium with benzene sulfonic acid. So 2 points, okay? So if you do this in concentrated acid, what you're going to do is create the fuming sulfuric acid is SO3, which is a gas, and H2SO4, okay? And this forms benzene sulfonic acid. Now, if you do this in dilute acid, this reaction is going to be shifted to the left. You know, it's like Le Chatelier's principle, shifting to the left. So if you do this in dilute acid, you can do the reverse reaction. Your sulfonic acid group can actually be removed from your, so dilute sulfuric acid. This can be removed from your aromatic ring and you can form just benzene, okay? So this first reaction is what I want to talk about. This is called the sulfonation. And I believe most professors would just ask you to draw that mechanism, but I can't speak for everybody. This is a desulfonation reaction, okay? This might be used in some very advanced syntheses, depending on the course you're taking, okay? So we're gonna focus on just this first one here in yellow, okay? How does this reaction work? Well, if you take benzene and you react this with fuming sulfuric acid, as I mentioned, fuming sulfuric acid is SO3, which is going to be the main component here, and H2SO4 is, you know, the solvent or the supporting guy, basically. And so let's draw the curved arrow reaction mechanism for this, okay? So SO3 is a gas, and so that's why it's called fuming. If you were to open a bottle of fuming sulfuric acid, you need to make sure you're operating in a fume hood, because fumes of sulfur trioxide would actually come out of the solution, and when this substance dissolves in water, it makes sulfuric acid. So your lungs, right, are moist, and so if your nasal membranes and throat and all that, so if sulfur trioxide, you inhaled it, it would react with all the moisture in your respiratory system, create sulfuric acid, and you would start choking. All right, so this is sulfur trioxide, and then that's going to react with H2SO4. We don't have to be too careful about that. In my class, I allow students just write H+. That's the really important part here, okay? So sulfur trioxide becomes protonated, and what you form is an electrophile, okay? So there we are with the positive charge. I'll put my lone pairs back on all of these oxygens. So this right here is the electrophile, all right? Weird looking, I know. It's really big, but let's just go ahead and do it. So that's the step that's unique for each of the reactions. In the next reaction, what we have is our aromatic ring. In this case, it's just boring old benzene. And I like to highlight that hydrogen here for you. And so we'll draw in our electrophile. And this looks very weird at first, but let's go ahead and attack the sulfur atom here and push the arrows towards the positive, right? The goal of the electrons are eventually to end up at, you know, some electronegative atom or the positive charge. And so this right here is benzene attacking. And what you form is an intermediate. That looks like this. Now it should start coming together and clicking in your mind. This right here is an SO3H group. We call it a sulfonic acid group. Okay, so that's a sulfonic acid group. So from now on, let's just abbreviate it SO3H, just to keep things simple. So the second step here is to regenerate our aromatic ring. So we have our benzene that is super stable, and here it's not too stable. So here you've got to watch out. We know it's being deprotonated by something. Now we don't have base in this solution. We have fuming sulfuric acid. So you could deprotonate with sulfuric acid, which I know seems silly. You could deprotonate with SO3H, that would be fine too. Something has to remove this hydrogen to remake the aromatic ring. And this structure that I've drawn here is extremely acidic. It's desperate to lose a proton to remake the really super stable aromatic ring. So here I'll just use SO3 as a deprotonating agent. And I don't know, maybe that's a really bad way to draw the mechanism, because I'm not really drawing an atom. So I'll draw SO3 out. I know it's a hassle, but once again, we just want to use one of these oxygen atoms to deprotonate, okay? Oxygen is also present in sulfuric acid. So that's going to give you the product. And I'll just resketch that out here. And you know, you form the conjugate acid, but I don't worry about that. All right, so that's the electrophilic aromatic sulfonation reaction, the curved arrow reaction mechanism, and that's all you really need to know at this point for this reaction. Thanks for watching.